Hello, my name is Arjun Verma, and this is my first physics lab on constant velocity. So the observation I was using was of a video of me walking across my room, and to the best of my ability, I utilized myself as an object with constant velocity, and this made this a challenge in both physics and my physical ability. Doing so allowed me to control my environment because I was able to use my room as a place to walk. So I was the object with constant velocity. In order to collect data from this video, I used Tracker. I plugged my video into Tracker and split it into 20 frame intervals, keeping the time intact so it would be accurate data. And I was able to measure my desk and use that as a reference distance in order to calculate the distance of the entire area. And I also placed my coordinate origin in the bottom right corner of the video with the negative x-axis pointing towards the left. I clicked my point of mass as I went along in order to gather data and make it accurate. The modeling could have changed in a lot of ways, but one of the main ways it could have changed was where the coordinate plane was placed and how the axes were aligned. So I kept it in the bottom right corner of my video with the negative x-axis pointing towards the left. By doing so, my motion was recorded to be in the negative x direction because I was moving towards the left. However, if I were to change the coordinate plane and say flip the axis, then my motion would be recorded to be in the positive x direction because I would be moving towards the positive x-axis. So from this data, I tried to formulate my model, and the basic idea of my model was that I had a constant velocity. So I assumed that my average velocity was my constant velocity, and as well as this, since I was moving at a constant velocity, there was no acceleration, and based off of Newton's second law, if there's no acceleration, regardless of what your mass is, there's going to be no net force. So I was also able to assume that there was no net force on the system in my model. The basis of my model was generated from the average velocity that I calculated from the data that I collected from Tracker, and I did so by calculating average velocity by taking the final distance, subtracting it from the initial distance, and dividing that by the time change to find that my average velocity was negative 0.275, a lot more numbers. And yeah, that was the basis of my model, and I also gathered the initial position from this and the time taken. I then designed this model in GlowScript using all the data that I collected. I did so by utilizing a preset velocity, position, net force, and time. I then created a loop that utilized all these things. So by preset, I mean I made all of these variables, and it created a loop that constantly updated the position based off of these variables and their initial values and updated a graph. I plugged in all the data that I calculated in the last step. So my average velocity, my initial position, I plugged it into my model and I ran my model in order to find a position versus time graph that looks very familiar to the position versus time graph from Tracker. I created a Python script to plot and compare the two lines, and I found that they were very close together. So my prediction and my model was very accurate in terms of predicting the actual data because it follows a very similar line, which means that the movement I was doing was very close to constant velocity. And I found, since I was using Python, I could do a little bit of extra stuff. And the blue line at the top displays the percent error at each separate time interval. And the overall average percent error was 2.89%, which means that my prediction was doing a very good job of predicting actual motion. So my experiment itself assumed constant velocity, and it assumed a net force of 0. And since the prediction did a pretty good job of assuming this, then that means that in real life the net force is probably pretty close to 0 because the prediction was very close to the actual value, which meant that it follows constant velocity because the prediction followed constant velocity. Which there's a lot of factors that could be going into my net force. And also, since I was walking, that's a very complex type of motion. However, there's a lot of things that we can analyze in terms of net force. There's gravity acting down on me and the normal force of the floor pushing up against me. And that created a net force of 0 because, gravity and normal force are always equal in terms of the y direction. So I was always constantly being supported. And in terms of net force in the x direction, so when I was moving, there was force being exerted by my feet against the ground to push myself forward. And there's friction being exerted by the ground as well as air resistance that were holding me back. And since my actual movement was very close to the prediction of constant velocity, then I can assume that my force exerted forward was about equal to the friction, and that ended up with a net force of 0. Yeah, that's essentially how I could describe the forces around me and how they were useful. But yeah, thank you guys so much for watching. I hope you enjoyed my video, and I hope that my experiment went well.